In this video, we are going to show you how to request the PDS search API from a Python Jupyter notebook. The material for this video is publicly available in this GitHub repository. You can run this demo and elaborate from it by following the instructions which can be found in the README. But for the sake of time, I already started Jupyter Lab and installed all the dependencies. In this notebook, we want to visualize spectrometer observations of the asteroid Bennu. We are first importing the dependencies, matplotlib to plot the observations, and astropy to read the fits data produced by the spectrometer. We then import this API client library that we provide to read from the web API. We need to configure this API client library with the URL of the PDS API. We're doing that here. And then we want to get the properties which describe the OVIRS spectrometer dataset. For doing so, without a priori knowledge of the description format of these products, we simply do a free text search on OVIRS using the keyword argument of this method. In the summary of the response, we can find the properties which describe the OVIRS product. As a reminder, the PDS API is transparently exposing the PDS4 information model descriptions of the product. What you can see here are the dot notations of the PDS4 properties. The properties we are specifically interested in for this demonstration are the data file reference, where we are going to read data from, the coordinates of the observations to select a specific location on the asteroid Bennu, and the range, the target range, the distance to the asteroid Bennu, so now let's extract the dataset that we want for this use case. We want to get the observations around a specific location, this latitude and longitude, and we want to get observations closer than 4 kilometers to Bennu. We are going to use this method product list again, but this time with the q= argument. This q= argument enabled to have complex queries, and I will show you on this example what the possibility we have here. So we want to get the observations made on the asteroid Bennu. We're doing that with target = Bennu, knowing is a lead vid identifier. We want to have observations made by the instrument OVIR. Instrument = OVIR as a lead vid again. We want to get observations closer than 4 kilometers, like lower than 4 kilometers to the target. And we want to have observations targeting a specific location on Bennu with this bounding box from 9 to 15 degrees of latitude and from 21 to 27 degrees of longitude. We're using these criteria to filter the products we want, and then we are going to filter the properties we want to get for this product. And specifically, we want the data files here in these properties. I'm going to run this query. And we're getting the result in the data field of the API response, this time in the variable closer products. So let's look at how many products we got. We got 4 products. Each of them is an object defined in the API client library that we can plot, or that we can print as a dictionary. So this object is contains metadata on the dataset, and specifically the properties we requested, among some others that are here by default. But we can see the one we want, the fits file, the URL to the fits file, the latitude, longitude, and target range, which value match the request criteria that we have. Now, to plot the data, we want to extract the URL to the fits file. We're doing that with this block. For each product in the result, we want this property, and we have a set of 4 URLs to fits file. We can easily plot these files using the AstroPy library to read the files and matplotlib to plot each of the observations. We can see on each of the detectors of the spectrometer instrument the 4 observations of this location on Bennu asteroid. This is it for the demo. I believe this is an interesting use case showing how efficiently we can extract PDS datasets using this web API. We are hoping this will stimulate your creativity and inspire you more science use cases using the Search API and Jupyter notebooks. Feel free to create your own pull request or tickets on this GitHub repository with your ideas and feedback. Thank you.